Hello again. We're now going to speak about the anatomy of a drill. This here is a standard twist drill. I find it better to start at the pointy end. So this little sketch up here represents the tip here. And we'll just go through a couple of the parts on it. So these straight edges, 1, 2, here and here, they are the cutting edges. The hollow part here, this section, that's known as the flute. And the part across the top here, that is called the chisel point. Now along the length of the drill, it's separated into two main parts. First part from here to here is called the body, and the body consists of the flutes, as we've mentioned, and this part is the land. Along the edges of the land here, they're guides. They're sharp, but they're not for cutting. The cutting edge is the only part that does any work on the drill. At the bottom here, we have what's known as a shank. In this case, it's a parallel shank. The drills up to about 13 millimeters have parallel shanks, and they're held in a drill chuck, like this. Now, as you wind the outer body, it opens and closes the three jaws, which will allow you to hold your drill. At some point, though, the torque forces on the end of the drill will exceed the holding forces on the shank. What happens in that case is this sort of wear. As you can see here from the shiny bit, what's happened is the drill has stopped in the material and the drilling machine is kept running, causing this wear. To counter that, larger drills of 13 millimeters plus will have a tapered shank. This particular taper is called a Morse taper. At the top of the Morse taper, there is a Tang. And the Tang is used for location and removal of the drill. Like so. This is just an extension, but it represents a drill shank. Goes in. That's already tight. Not put a lot of pressure on it. And with a little wedge, you can just click and it pulls out. So the Tang is for releasing the drill. You'll notice at the end of the drill here, if I zoom in a little bit, at the end of the drill, here are your two cutting edges, 1 and 2, and then you have this ground area here. You'll notice that the bottom here is lower than the top there. So there to there, obviously across the diameter will give you an angle, like so, and that angle there is known as the relief angle. The relief angle is there to ensure that the sharp bits do the cutting. Otherwise, if it was just flat, it would get to a point and it would just rub, and you would do very little drilling. The third type of drill, it's not really a drill, it's called a reamer. Here's a reamer. Again, Morse tapered with a tang at the end. Oh, put that way. Morse tapered with a tang at the end. You'll notice the body itself is much more sturdy, and what it's used for is reaming out a hole. Obviously, I'll write reamer. It hones the hole to an exact size. If you were to drill just with a normal twist drill, say you had a 10mm drill, you drill your hole, and if you're needing an accurate hole size, that's probably not sufficient. A 10mm drill will drill anywhere between 9.9 mil, depending on how worn it is, up to 10.2, something like that, due to the flex in the drill. The amount of material in the body of the reamer will stop that. So the way to use it would be to drill 0.2 mil smaller than you're intending, and then follow up with a reamer. This reamer, because it's got the Morse taper, is for use on a machine. You do get ones with parallel shanks and square heads, and they're for hand reaming. Difference being, there's a very slight taper on the end to allow you to start drilling by hand, or reaming by hand. So, to go through it once more, we've got a parallel shank twist drill, a Morse taper shank twist drill, and a reamer.